Section B, multiple choice questions, paper 3, A-level, June 2022. Which atom in the ground state contains at least one unpaired p electron? It's going to be oxygen. Just look at the electrical configuration, and you can see it's got, well, oxygen's got 8 electrons, 1s2, 2s2, 2p4, obviously 3 orbitals. No, sorry, they're going to want to form by themselves, so you're going to have an unpaired p electron. That's all I'm trying to say. So the answer is C, oxygen. Complete combustion of this much produces this much carbon dioxide, which could be the formula of acid, and it gives us this as well. But we've got the moles of this, 0.0100. We can find out the moles of NaOH. Moles is equal to 1.0 times by 20 divided by 1000. 0.02. So what we need is something with 2 COOH is, and also 2 carbons. So it's going to be C. H groups, and it's also got 2 carbons. 8 vegetables have no delocalized delocalized electrons. Graphite does. Methylbenzene, electron delocalization, will have delocalized electrons. Polypropylene and sodium. Now, sodium. What's sodium? Na+. What is it? It's a metal. What do metals have? Metallic bonding. And what is metallic bonding? The definition, you should know. Positive charge, C delocalized electrons altogether positive charge. Something like that. It's not the full definition, but you can see the C of delocalized electrons, so it does have delocalized electrons, so the answer is polypropylene. That's just breaking it down for you guys. Question 9, which is the correct statement about the gas molecules at high temperature? Then what molecules with any given energy? No. Same molecules. Because what happens is, you know, you got energy here, you got your number of particles here, I just write particles, and it says temperatures increase, so you got your normal Maxwell-Boltzmann curve, and then what happens is the peak shifts to the right and it goes a bit lower. So it's still the same molecules at any given energy. More molecules mean energy, that's false. More molecules, most probable energy, no. Increase in the most probable energy of molecules, yes, because we're moving to the right, so we're going to have more kinetic energy, so the increase in the most probable energy of the molecules. Which of these, this is a pretty hard question. I've seen a Maxwell-Boltzmann curve, so I would learn this answer, this question off by heart. Definitely could see it being a repeat question. It's very tricky for Maxwell-Boltzmann curve question or marker. Which of these oxidation states is correct? Chlorine in Cl2 is -1. That's false. Chromium in that is +7. We're going to have to break this down now. Well, oxygen -2, -14. Potassium's in group 1, so it's going to be +2. -14 plus 2 is -12. Therefore, Cr is going to have a +6, not +7. So no. Fluorine in F2O is -1. Well, let's look at D. Hydrogen NaH is +1. Well, Na is +1. So yeah, it's not going to be D. So anything hydrogen would be -1, right? And fluorine in F2O, yes. Remember oxygen. Difluoride, remember the special case with oxidation states. In this case, the oxidation state of fluorine is -1 and oxygen is +2 instead of -2. Just remembering your special case. Which change of hydrogen electrode has no effect on electrode potential? Remember, for hydrogen electrode and electrode potential, 3 things you need to keep the same. Concentration of the hydrogen ions, 1.0 moles per minus cube, I think. The temperature, and the temperature at room temperature and the pressure of 100 kilopascals. So concentration does have an effect, pressure does have an effect, the temperature does have an effect, after the surface area has no effect on the electric potential. And you do need to know those 3 conditions for electric potential anyway off by heart.
12 some electrical potential data shown, which is correct statement by the cell. Let's look at C. The maximum EMF of the cell is 0.89. Well, to find out the EMF, it's going to be reduced minus oxidized. I'm pretty sure. So it's going to be minus 0.13. Well, it's going to be minus 0.13 minus 0.76, which is plus 0.63. It's not that. Zinc is deposited. That's not true. Concentration of lead to ions increases. No, electrons travel in the external circuit from zinc to lead. That is correct. Which cannot function as a Bronsted-Lowry acid. Remember, this, it loses a H+, right? And we're trying to find which cannot function. This can lose a H+ to form NH3. This can lose a H+ to form H2O. Now we're left with A and B. Well, with B, if we lose a H+, we'll form CO3 2-. That's fine. Whereas with A, we have no hydrogens here, and we'll form, that cannot function as a Bronsted-Lowry acid, therefore it's A. And remember, Bronsted-Lowry acid loses H+. What's the pH of this much solution of this acid? Well, pH equals minus log 10 of H+, concentration of H+ ions, hydrogen ions, and we've got H2X. So what we need to do is do this times by 2, which will give me 0.040, and then do the pH of that, minus log 10 of 0.020 times by 2. 1.397, 1.40. That's the tricky part. It's got 2 hydrogen ions. It tells us it's a strong acid. It's diprotic. Releases 2 hydrogen ions. So we need to times this by 2. Then we can do the classic pH is minus log 10H plus and substitute the value of 0.020 times by 2. 0.040. Which two solutions would mix form a solution pH greater than 7? We've got HCOH and HCOK. Weak acid and salt. No, it's going to form pH definitely less than 7. Potassium hydroxide and CH3COH. Strong base and a weak acid. Yes, because that's going to lead to a massive change. Therefore, the pH will be greater than 7. Which ionization energy needs less energy in this process? Less energy. Needs less energy than this process, not more. Well, this is definitely going to need more. And so is this and this. Whereas with aluminium, it's definitely going to need less energy than this process. Which statement is correct about the group 1 metal elements? CS plus ion is more negative enthalpy of hydration or B plus ion? No, that's false. Enthalpy of atomization of potassium is greater than enthalpy of atomization for sodium. That's false. The melting point of potassium is higher than the melting point of sodium. That is false. Second ionization of rubidium is lower than the second ionization energy of lithium. That is true. What's the reason for adding nitric acid? D. Very easy. Prevent precipitation of other soil compounds. Which pair of reagents reacts to form a tetrahedral complex? Well, it's definitely going to be D, because we can see here the Cl3 and the Cl, and therefore we'll get FeCl4 with tetrahedral, so 4 bonds, the Cl. Whereas with the rest, we won't. What type of reaction takes place? The only type of reaction that can take place in this case, definitely not precipitation or redox. So left hydrolysis, ligand substitution. It's definitely going to be ligand substitution. What volume of this needs to oxide that much completely? So we need to read it carefully. What we're trying to find, the volume of this needed to oxidize this much, vanadium ions, which is this. So to find out moles of this, well, we're going to do 0.10 divided by 5. 0.02. And remember, moles concentration times volume. Constant moles concentration volume. Volume is moles divided by volume. Put that in the calculator, and you should get 1. So therefore 1.0. 2-bromopropane reacts with propene to form 2,2-dibromopropane. What is the name of mechanism of reaction? Electrophilic addition. No, because that's with the alkene. Elimination, well, that's when it breaks apart, and that's usually with the OH minus ion, not with bromine. So we're left with free radical substitution, nucleophilic substitution. Well, it's definitely going to be free radical substitution, because all we're doing is adding bromine, 2-dibromo, 2 bromies, adding a bromo, just 1. Whereas with nucleophilic substitution, we replace it, we substitute for it. Which compound is formed from bromoethane in nucleophilic substitution reaction? Bromoethane, methane, ethane. So we need a CH3CH2. Definitely not that. That's good, because what would that form? That would be methane. So yeah. Whereas B, yeah, because you got CH3CH2 NH2. And yeah, you can replace it with Br, so yeah, B is the correct answer. C, well, that's an alkene, definitely not a nucleophilic substitution reaction. And this one, the SOSO2 or H, the alkyl, is this alkyl hydrogen sulfates? Yeah, which are alkyl hydrogen sulfates. So in this case, ethyl hydrogen sulfate, alkyl hydrogen sulfate. Well, that is a, what is it called? It's not a nucleophilic substitution reaction, I know that for sure. So yeah, that's it, all that matters really for this question. But I'm pretty sure it is a electrophilic addition mechanism. Yeah, I think it's that. Which statement is not correct for both primary and secondary alcohols? Easy oxide to carboxylic acids by acidified K2Cr2O7 solution. That's wrong. For both. Primary, yeah, aldehydes oxides to carboxylic acid. Secondary, no, it's not going to easy oxidize to carboxylic acids. Which compound has isomer of ethyl ethanoate? If you draw it out, methane, you know, you got your O and your ethyl ethanoate, your ester, right? 1, 2, 3, 4 carbons. Whereas methyl propanoate, methyl, so a butyl methanoate, 5 carbons, so that's going to be right. Methane, ethane, methyl propanoate, methyl, so it's got 1 carbon. Propanoate, so it's got 3 carbons. So we'll have a total of 4 carbons, so it can be an isomer of that. Whereas a methyl butanoate, so 1 methane, ethane, propane, butane, so that'll be 5 carbons. Propanoic acid, that's 3 carbons. Or is it 4? Well, it can't be that anyway. Butyl methanoate, methane, ethane, propane, butane. So that'll give me 5. So therefore the answer is B, because it's got the 4 carbons. So it's just rearranged differently. Still got the same carbon structure. Which compound is amide? Amide has got to have C double bond O and your NH. That's all you need to know. That's not it. And there we go. CONH. It's got to be B. So let me just write it down. Amide. So you can see these multiple choice questions. They're not really. Some of them are trial and error, but a lot of them are just how well do you know the specific point in the specification on amide. and you just need to know the specific key parts of an amide. In this case, CONH. Look for that, and you find that B. You don't need to look for anything else. Which compound can form a polymer with superoyl chloride? Well, we're going to look for diamine, because that's a diacyl chloride. So diamine A. It's got two NH2 groups. Whereas with B, it's diacyl chloride, so we can't react both of them. C, that's got methyl and NH2, so that can't be it. And D, it's two carboxylic acids. No. 28. Which polymer is not hydrolyzed when heated with aqueous alkali? Kevlar is hydrolyzed. Nylon 66 is hydrolyzed. Polypropylene is not hydrolyzed. Terylene, I think that is hydrolyzed as well. Yeah. 29 was the main species present in aqueous solution of aspartic acid at pH 14. So pH 14, that's a very high pH. So what does that tell me? Low H pluses, right? Concentration H plus ions. Remember the pH equals minus log 10 H plus. If pH is really high, H plus is really low. If H plus is really high, pH is really low. Vice versa. So we have pH is really high, 14. Extremely high. So therefore, our answer has to not, it's got to have a low H pluses. So it wants to accept the proton. Whereas in this case, it's got the H pluses. Can't be that. In this case, it's got your extra H plus. This case, yes, it does not have a H plus here, but it has a H plus here. And therefore the answer is D. It can form except two protons. So CH2COOH, COOH. Which type of reaction is not involved in this reaction sequence? Well, this is nitration, adding an NO2 group, nitration. This, well, we're going from COCH3 to CHOHCH3. So nitration is involved, so that's out. We're going from is that a ketone, an aldehyde? That's definitely reduction. That's esterification hydrolysis. And then we're going from here to here. That's reduction. And that is that hydrolysis, esterification? That's esterification. Adding an ester link. You can see that OCR. So therefore hydrolysis is not involved in this reaction sequence. Which pair reagent does not produce ethanol? Well, that will methane, ethane. Just swap it. This case, methane, ethane. That will. Well, let's draw ethanol. Methane, ethane. CH3CH 2OH. CH3 CH2OH. CH3 CH2. So I think the answer is B then. 32. Which type of interaction between polypeptide chains mainly responsible for maintaining the secondary structure protein form of an alpha helix? Memory game. It's hydrogen bonds. Which statement about this is correct? It decolors bromine water. That is false. It's saturated. No double bonds. Is a component of DNA? Nope. No bases. Is insoluble in water? No. It reacts with hydrochloric acid? Yes. Which compound can be dehydrated to form an alkene? Remember, alcohols can be dehydrated. It's just learning these key things. Alcohols can be dehydrated to form alkenes. So which one's an alcohol? That's not an alcohol. That's a carboxylic acid. This is an alcohol. It's got your OH group, your hydroxyl group. Therefore the answer is C. That's simple. Like, it looks like a really hard question. I found it really hard. But once you just learn, like, if alcohols will dehydrate to form alkenes and just look for the OH group, it's going to be a C. Which compound is not a 2-amino carboxylic acid? That is because remember when we're naming carbons in a carboxylic acid, you always start from the COOH carbon. So that's going to be the first carbon. That's on the second carbon. In this case, that's going to be the first carbon. That's going to be second carbon. That's going to be the third carbon. So that's going to be 3-amino carboxylic acid, and therefore that is not 2-amino carboxylic acid. These two, that is 2, that's 2. So the answer is B. It's not 2-amino carboxylic acid. And that is the end of multiple choice questions.